This brings us to the periodicity theorem, and pretty much what the periodicity theorem is telling us is that every time you go through a full cycle or full period on the sine, cosine, or tangent graph, then what's happening is all your values repeat and you're going to get the same thing. So, for example, for all real numbers x and any integer y, the sine of theta plus 2 pi. So I don't know if you remember that problem that we did on that one lesson master, where I gave you an angle like 5 pi over 6 and said, give me another angle that's the same as 5 pi over 6, and you just added 2 pi to it. Well, according to the periodicity theorem, we can add 2 pi as many times as we want, so we'll say times n. And you'll still just get the sine of theta. You're going to get the same thing. Same thing with cosine. So if I'm at theta and I go around the circle again, I can go around the circle as many times as I want and I'll still get that same cosine. I'll show you what I mean. So here we have a circle, a unit circle, and if I'm right here, whatever the sign is right there, if I go all the way around the circle again, I'm going to get the same sign. If I go around the circle 3 times, I'm still going to get the same sine of theta. Same thing works with cosine. Every time you go all the way around the circle, you will get the exact same thing. Now, tangent is a little bit different because you don't have to go all the way around the circle because tangent repeats every pi, so it's just plus pi times n. And you will get the same tangent of theta. I'll show you what I mean. So with tangent of theta, if I'm right here and I want the same tangent, I only have to go halfway around the circle, and then it will repeat. Because you know tangent's positive here and it's positive here. If I started here, where it's negative, and I go halfway around right here, it's also going to be negative. So it repeats every pi as opposed to every 2 pi. We're going to use that periodicity theorem, and the whole idea of the periodicity theorem is to figure out, okay, if I'm given the sine, if I'm asked to find the sine, cosine, or tangent of an angle that's not on my unit circle that goes from 0 to 2 pi, where on the unit circle would it be? For instance, I'm going to draw a little sketch of my unit circle here. I'm just going to, for right now, draw in the 4 corners. And I know that this is 0 or 2 pi. I know that this is pi over 2. I know that this is pi. And I know that this is 3 pi over 2. So, I'm wondering, number 1, cosine of 42 pi. Where would that be? Well, 0 pi is here. 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. I could keep counting, but I realize that all my odd pi multiples are on the left side, and all my even multiples of pi are on the right side. 0, 2, 4, 6, 8, 10, 12. So 42 pi is going to be right here, which means finding the cosine of 42 pi is the same as finding the cosine of 2 pi. Just means I've gone around the circle a bunch more, but I've still landed here. And my cosine right here, my x-coordinate, is 1. Okay, so let's look at number 2. Where would 71 pi be? That would be over here, because 71 is an odd multiple of pi. So finding the cosine of 71 pi is the same as finding the cosine of pi. And the cosine of pi, the x-coordinate at pi, is negative 1. Let's look at number 3, the cosine of 23 pi over 2. All right, I need to think about where 23 pi over 2 would be. So first I think about what is 23 divided by 2. 23 divided by 2 is 11.5 pi. So 11.5 pi, or 11.5 pi. Let's just put it that way. Well, so let me put that like that. 11 pi would be right here, and half of a pi is right here. So it's the same as finding the sine of 3 pi over 2. That's what 11.5 pi is. And the sine is the y-coordinate, so it's -1. Let's look at -15 halves. That would be -15 halves is -7.5 pi. So -7 is here, right there, and a half. So if I'm going in the negative direction, that would be up here at a half right there. So that's the same as finding the tangent of pi over 2. And the tangent, remember, is y divided by x, 1 divided by 0, and so that's undefined. Let's go to number 5. The sine of 4,560. I need to figure out, this time I'm in degrees, so I want to figure out how many 360s are in 4,560. So 4,560, this is what I'm doing on my calculator, divided by 360. And I get that that's 12 2/3. You have to remember, 12 revolutions, 12 brings me here, full revolutions. Doesn't matter if it's even or odd, because this is 360 is a full revolution. If I go all the way around to here 12 times, and then I have 2/3 of a revolution left, 0.6 repeating. So 2/3 times 360, so I got 12.6 repeating. So the 12 means I just land here. All that matters is the remainder. I have 2/3 left over times 360, and that gives me 240 degrees. So I am finding the sine of 240 degrees. Let's make sure we understand that. I divided and figured out that I had 12 full revolutions, and then 2/3 of a revolution is left over because I divided by 360. So 2/3 times 360 means I have another 240 degrees to travel. And that's what I'm taking the sine of. And the sine at 240, you need to think about where 240 would be. Right here is 180. And then I'm going to go, if I only go 30 more, that's 210. 240 is going to be where my pi over 3 family is. And my ordered pair at my pi over 3 family is 1/2 square root of 3 over 2. And so square root of 3 over 2 is my y coordinate. So it's going to be right here. And that's where I have 1/2 comma square root of 3 over 2. And both sine and cosine are negative in this quadrant. All right, number 6. Cosine of -2,655. Well, let's see how many 360s go in a 2,655. So I'm first taking 2,655 and dividing by 360. And I get 7.375. Again, this is 7 full revolutions because I divided by 360. So I land here, and then I have to go in the negative direction 0.375, which means I have 0.375 times 360, and I get 135. Now remember, this is negative, so I'm going to go negative 135 degrees. So if I'm here, negative 135 is at my pi over 4 family right here. And at my pi over 4 family, both my sine and cosine are the square root of 3 over 2. So let's write this down. I'm finding the cosine of negative 135 degrees. So that's going to be at square root of 2 over 2. And cosine in this quadrant is negative. Notice it's important that we find not only the correct number, but the correct sign, as in plus or minus. Okay? All right, let's go on to number 7. Tangent of 3,600. So tangent, see what is 3,600 divided by 360, and I get 10. That means 10 full revolutions, which means I'm landing right here. I'm at 0, so I'm just finding the tangent of 0, which is 0 divided by 1, which is 0. Number 8. If I know the cosine of 5 pi over 7 is negative 0.623, can I find the cosine of 19 pi over 7? All right, let's think about this. I know I need to find a way to write 19 pi over 7 using 5 pi over 7. So 19 pi over 7 is equal to 5 pi over 7 plus 14 pi over 7. This 5 plus 14 is 19. Well, I know that 5 pi over 7 plus 14 divided by 7 is just 2 pi, which means 19 pi over 7 is the same cosine as 5 pi over 7, because all I've done is gone around the circle again, so I get the exact same answer, because all I did to get 19 pi over 7 from 5 pi over 7 was go around the circle one more time. Right. So number 9 says that the cosine of 2.3 is approximately negative 0.67. Find 3 other values of theta where the cosine of theta is negative 0.67. Well, we know that cosine of 2.3 is negative 0.67, so we could take cosine of 2.3, and this must be in radians because there's no degrees, so just go around the circle again, so just add 2 pi. Well, that is approximately the cosine of 2.3 plus 6.28, so that gives us the cosine of 8.58. Let's go to our next one. We could find another one by saying the cosine of 2.3 plus 2 pi plus 2 pi. We could go around the circle twice. Well, 2 pi plus 2 pi, isn't that simply 4 pi? So we're finding the cosine of 2.3 plus, when I put 4 pi in my calculator, I get 12.56. So that is the cosine of 14.86. So if you were to put in your calculator cosine of 2.3, you'll get negative 0.67. If you put in cosine of 8.58, you will also get negative 0.67. Cosine of 14.86, you get negative 0.67, because all we did was go around the circle once, go around the circle twice. This time, let's go around the circle the other direction and subtract 2 pi.